Today we're going to be looking at two new tests called the ratio and root tests. When you have a series where there's many exponents, we use a test called root test to help us figure out convergence or divergence. So how that root test works is if you have a positive series, a sub n, and you take the nth root of that series and the series, the limit comes to be less than 1, that means you end up with a convergent series. If you take the nth root of the series and the limit comes out to be greater than 1, then your series ends up being divergent. If it's the case where the limit as you go to infinity of the nth root actually equals 1, then the test fails, and then you need to use some other test to determine convergence or divergence. Why does this root test work? Well, if you take the nth root of the series, and let's say that it comes out to be a over b, some fraction, then there is some n where if we say that it's less than 1 but also less than some r, that means if we were to take the nth power of all this, we would end up that taking this to the n power would cancel out our root here, so we just end up with a sub n. That would be less than r sub n, which would still be less than 1 because 1 to any power is still 1. So if the terms are eventually smaller than the convergent series here, that means that they would be convergent by comparison to geometric, because if you have a geometric series that's less than 1, you know it's convergent. So it's using comparison to geometric series. Same thing if it ends up being divergent, where it's greater than 1. That means the nth root's greater than r, which is greater than 1. And so if you take the nth power of all these, it ends up that a sub n is greater than r, which is greater than 1. But we know by geometric, if your r is greater than 1, that you're going to have a divergent one. So it's again comparing to geometric series that we can make that conclusion.